Hello and welcome to the physics module brought to you by CJR Gaming. My name is Christian Richards, and in this episode I wanted to introduce the player update background thread. We already created the class itself, but in this episode I want to go ahead and flesh it out. Now you might be asking, well, why do the player update background thread and not the actual physics background thread? And in reality, we need them both. But the reason I'm starting with the player update is because I want to be able to get my updates so that when the physics is working, we can already test and see and make sure that the physics are actually working, as opposed to sitting around and having one chunk of code that then we still have to write the second piece of code before we can actually see any results. So I'm going to begin with the server code opening up here in Visual Studio, and the first class I want to take a look at, rather than immediately jumping into the background thread, is I'm going to create a new message object. And this message object is going to be called player movement. And the player movement class is actually going to be used to pass information back and forth about what's going on with the player at the moment. So I want to mark this as serializable, and then I want to come in and I just want to give it a bunch of attributes here. The first one being the object ID, and these are all just going to have a bunch of getters and setters. The next one I'm going to have is facing. And then the third one is going to be a Boolean for whether they are walking or not. The fourth one is going to be another bool for whether they are ducking or not. The fifth one is going to be for whether they are actually moving or not, because they might be ducking, in which case we want to play a duck animation, but they might not be moving, so they might just be ducking and just standing there as opposed to moving around and at that point either walking or not. The next one I want is a float to know which direction is forward, and then another float for right. Now what these are going to be are a set of values so that we know if they're moving forward or backwards. I'm using a float so that I can use +1, -1, or 0. And then same thing with the left or right. With the right, if it's positive, it's going to be going right. If it's negative, it's going to be going left. If it's 0, they're not moving side to side at all. And then the last one I want is a bool for jump to know whether or not they are currently jumping or not. Now this data mainly is used by the physics class to send this information to the client, but we can also use it to send from the client to the server to say what we want to do as opposed to what someone else is doing. And it's just doubling up on this class for us, which works out very nice. The next thing I want to create is actually an interface, and this interface I'm going to call iPhysics. Now the reason I'm creating this interface is because let's say that I decide I don't want to use bullet physics anymore. I want to use like the digital rune physics. Well, in order to keep those things separate, I'm going to create just a generic interface for the physics class, and then at runtime we can determine, are we going to use digital rune, are we going to use bullet physics, is there maybe a third one that I don't know about that does what we want it to do, and this will just give us a generic physics interface so that we can work with the update background thread and hide away which version of physics we're using. The few values we're going to have here is first a position with just a getter, and this way we can ask the physics, hey, what is our position of our player? Next is going to be a bool called dirty. It's going to have a getter and a setter, and this is just so that we know whether or not our position has changed or if anything else has changed, so that we know whether or not we should send an update through the player update background thread. Next, I'm going to use that player movement class that I just created. And all I'm going to do is call this movement. And it's going to have a getter and a setter. Next is a float for the move speed, so that we can set what the speed is, whether they're walking or running. When we send information back to the player, we'll want to know how fast they're moving, and that's what the move speed is for. Next, we have a vector 3 of walk direction. Oops. And go ahead and grab the using statement there. And it's going to have a getter and a setter. And then the last thing in here is we're going to have a bool of moving, so that we know whether or not the physics background thread should try and run this client because they're moving or if they're stopped, and then be able to send things like the stop movement value, things along those lines. So there's our interface. Pretty simple. It just contains those few values. And next I want to create the actual physics model that we'll be using here, which is going to use bullet physics. So I'm actually going to say, I'm actually going to call this bullet physics. And I believe I misspelled that. I did misspell that. There we go. Bullet physics, and just rename that file to match. Mark this as a public class, and then I'm going to inherit from iPhysics. That way I have everything I need there from the physics itself. So we'll go ahead and implement these members, which right now are just going to come in with getters and setters and private values and things like that. But before we get into those, I want to create a few other items here for the bullet physics. First, I want to mark a private bool that I'm going to call underscore dirty. Now this is the value that we'll use to hold the value, because we're going to override the getter and the setter of dirty to do things when we set those values either to true or false, and we can work with what we need. Same thing for our position. I'm going to set that equal to a new position just right off the bat when it comes in. The next thing I want is a public iCharacter controller interface. And this is actually one of the bullet physics values. I'm going to call this character controller, and I'm going to just have a getter and a setter for that. The last one that we're going to create is going to be a private float of move speed, sorry, that's not a private float of move speed. That's already the move speed that we have down here. I don't actually need to create that getter and setter. The position is not going to have a setter. It's only going to have a getter, and all that's going to do is return that underscore position, because we'll be setting that elsewhere. And then we'll get started right into this dirty class. Before I do that, I really quick want to grab the walk direction and move speed and actually move those up above, because we're not going to override those values there. And then we'll just jump right into the getter on the dirty. And then also setting up the setter. There we go. There, like that. So the getter, what I'm going to do is I'm going to say if the character controller does not equal null, and I can cast that character controller to a kinematic character controller, then what I'm going to do is I'm going to get the ghost object from that kinematic character controller, and I'm going to check and see if that doesn't equal null. The reason I need the ghost object is because that's how we actually get our position data, is through this ghost object. So what I'm going to do then is I'm going to say if underscore position does not equal position, which we'll define up here, position position equals, and then we're going to cast that to a kinematic character controller, getting the character controller, getting the ghost object, and then I want to get the world transform. So if I get the world transform, I'm going to put that into position. Now right now our position class isn't able to convert between a matrix and the position. We'll be writing that function that we need here shortly. But if this position does not equal our private held position that gets returned with the capital P position getter, then what we are going to do is we're going to say underscore position equals that position. And then I'm also going to set my dirty flag equal to true. And the reason for that is we now know that our position is different from where we expected it to be, and we want to be able to do something about that. And then no matter what, we're going to return underscore dirty. I'll let that refactor that. There we go. Or sorry, reformat that. And then my setter is going to be pretty easy. I'm just going to say underscore dirty equals value. So we need to take care of this error right here where we have this position and we're trying to set that position equal to a matrix. And so in order to do that, we're going to use what's called an implicit operator. If I right click on position and go to the declaration, we already have one of those. We have the public static implicit operator for position data, but we don't have anything for a matrix. So I want to go ahead and write that. I'm going to say public static implicit operator position, taking in a matrix called position. And what I'm going to do is I'm going to return a new position that is going to take the inputted position dot translation dot x, and then that same position dot translation dot y, and then that same position dot translation dot z. So there we go. We're going to take in this matrix. We're going to take its translation, which is its actual position, away from 0, 0. 0, 0, 0, because we're at the very center of the world. We're going to take that translation, and that is our new position. And if we go back to the bullet physics, you'll now see that that red squiggly is now gone because it's taking this and it's implicitly casting it to a brand new position that we can then set our position equal to. So that takes care of our dirty flag. We'll be using, most of the time we'll be just setting the value equal to false. And then any other time we're going to be coming in and we want to check to see if we need to update that position. And we'll be doing that within the update background thread. And I'll show you how that works once we get there. Let's first finish off the rest of this function. My getter for my player movement is just going to return underscore player movement, which is just going to be defined up here along with this private position. It's just going to be a private player movement, and I'm just going to call that underscore player movement, just like that. So we get the return value for it. My setter, on the other hand, is going to contain most of what we're going to do later on. For right now, I'm just going to say underscore player movement equals value. Later on, what we'll be doing is anytime we set the player movement, we are going to want to recalculate what we're doing within the bullet physics engine so that the physics background thread takes this player movement and actually does something with it. For right now, we'll leave it at that. Just know that we are going to create a bunch more data after that. And then this last function, or this last property that I missed, I'm going to, yes, I'm going to take it and go ahead and paste that up underneath moving, just because we're going to use just the base getter and setter. So there we have the initial setup for our physics, but now we need to actually be using it somewhere. Now, in order to use it, because we're using AutoFac, I want to place it into my CPlayer instance. So if I come down here to my CPlayer instance, what I want to do is I actually want to add this in to my list up here. So I've got my region, I've got my player known list. The next thing I want is my iPhysics. And then, since this does not come from any of our other classes and we're not passing it down anywhere, I'm just going to say physics equals physics. And then ReSharper can just create for us that property, which is just going to have a getter and a setter. So I'll just come in here, take that, do that with both of them, and then if I just hit that, it'll pull it up onto that same line, like so. So there we go. We have our protected iPhysics, and actually I want to go ahead and mark this as public because there are other places that we will be looking up what physics we're using. And then before I forget, I want to go into my region server, and I want to come in here and I want to say builder.registerType. I want to register that bullet physics class, and then I'm going to say .as implemented interfaces. That's an easy way of saying take whatever it is and actually register it as the interfaces that it inherits from. In the case of bullet physics, it's pretty easy. It's just inheriting from iPhysics. If we were to do that same thing on the CPlayer instance, it would actually end up registering it as an iPlayer, an iClient data. It would also register it as an iPlayable, an iCharacter, and an iObject. But since we don't need all of those for the player instance, we only register it as a client data. But just know that when you call this as implemented interfaces, it will go down through its entire list of interfaces and register it for each one of those types, so that when you try and include it, such as here in the constructor, it'll just automatically come along with it. The other thing I want to do with my CPlayer instance is set up a destination. So I'm going to say destination equals a new position. So there we go. I have my destination coming in, I have my physics being set up, and now I have access to that once I am in my player update background thread. So let's begin with that. The first thing I need is I need a region, or I need the region class itself that I'm going to call region, and I'm just going to have a getter and a setter for it. The other thing that I need is a private bool of is running, and it's just going to be set to false right off the bat. The next thing is that I'm going to have a public, my constructor, which is going to be the player update background thread. It's going to take in that region, and it's just going to set my capital R region equal to that lowercase r region. And again, we don't have this inside of the region server, so I actually need to add it. So let's go into my region server here, and what I'm going to do is I'm going to come in and just say builder.registerType, and then yes, player update background thread, and then I'm going to register that as an I background thread. And then I also want this to have a single instance, so that anytime we ask for the background thread, we will always return this. Anytime we ask for the player update background thread, it will always return to us that one background thread, as opposed to any other background threads that we might have. All right. Now that we have that set up, let's go ahead and actually write the setup function, which is nothing more than removing the not implemented. After that, I want to take a look at my run. What the run is going to do is it's going to first create a stopwatch. And the stopwatch is just part of system diagnostics, but it gives us access to the millisecond value as it is running through this thread. I'm going to then say timer equals new stopwatch. I'm going to say timer.start, and then I'm going to set is running equal to true. Then I'm going to say while is running if my timer dot elapsed is less than a time span created from milliseconds of 100. So if the timer is past 100 milliseconds, it's going to run through this function, and that's going to say if my region dot num players is less than or equal to 0, then what I'm going to do is I'm actually going to do a thread dot sleep, and I'm going to sleep it for 1 whole second. And then this is going to come from system.threading. There we go. And then I can continue. So what this is essentially doing is it's saying every 100 milliseconds, if there are no players, go to sleep for a full second. So it'll sleep for a second at a time as long as there are no players within this region, which is good because then we're not chewing up useless cycles, trying to run updates when there's no one here. After that, I'm going to call the update function, and I'm just going to pass in the timer.elapsed, and then I'm going to say timer.restart. So it's going to set it back to 0, and it's going to start it all over again. The stop function, anytime we call stop, it's just going to set the is running equal to false. That way we shut down cleanly. We can release the thread, we can release the memory, do all that kind of stuff, but we're not just sitting there still trying to run even after we are attempting to shut it down. So lastly, I need this private void update, and it's going to take in a time span that I'm just calling elapsed. And then I'm going to use the parallel. I'm going to use parallel dot for each, and I'm going to say region dot all players dot values dot where I'm going to say a. So for every player value that I get back, I want the a dot physics dot dirty, and a is C player instance. So what that means is that I also need to add in my physics into my interface, because you'll see that it can't figure out what physics is, and that's because my values that I'm being returned are of type iPlayer. So we have this wonderful to-do in there that I created, and all that's going to be now is it's going to be iPhysics, physics with a getter and a setter. So if I save that, go back to my background update thread, okay, so far so good. We now are finding everything that's dirty and is a player instance. Now the reason we're doing this for a player instance is because we want that player instance to broadcast to everyone else that it has moved. And the only way we can do that is if we're coming back and we are that C player instance. So then what I'm going to do is I'm going to cast this to that C player instance. So once we've determined that it is a C player instance, we're going to cast it. That way we don't get any illegal casts. And then from here, I want to call send update. And again, we haven't created send update, but that's going to be created right here. Public void send update, and it's going to take in a CPlayer instance called instance. And I'm going to say if instance does not equal null and instance.physics.dirty. So you can see we're checking to see if it's dirty. If it's dirty, it's culling through and actually it's actually coming through to the physics itself, and it's going to do this check. It's going to see if that position has been updated, and if that position has been updated, it's automatically going to mark that dirty for us. So each time we come through here, we're checking to see if the physics engine has updated our position so that we can update this position before we try and send out an update to the client. And then all this is going to do is say instance.broadcastMessage. It's going to send a new move to location, taking in this instance, and then I'm going to say instance.physics.dirty equals false. And that's just so that if it comes back in here and either we don't have a character controller, or for whatever reason our position is no longer the same, we'll be returning that false instead of returning whatever it was previously, because we might still have it marked as true if we don't mark it physically as false, because our position has now been updated, and we have that in there to say, okay, yes, I've actually sent out the message saying I've moved to that location, so my position is no longer dirty. The client now knows we are at the correct position. And so that's where that's what we're doing with this update. All right, so that's everything we needed for this function, or I mean for this background thread. We now have it to where it's in our region server. If we recompile the region server, and let's just double check that this all builds correctly. And what it's going to do is it's going to register that that background thread. That background thread is then going to go ahead and take care of updating us anytime our position has changed within the physics. Now, right now, it's not going to do anything because our position hasn't changed. We haven't even really added them to a physics engine yet. This is just saying, hey, if the physics for whatever reason has been marked dirty, send out an update to the new location so that each of the clients can push it wherever it needs to go. Now, there is one last thing I want to cover, and I actually want to do away with several of these registrations. And the way we're going to do that is we're actually going to use something along the same lines as this register assembly types. What I want to do is I want to type up builder.register assembly types, just like that other one. I'm going to pass in the assembly.getAssembly, passing in get type, which is going to get this class's type, so it's only going to get everything out of this class's DLL. And then all I'm going to do is I'm going to say dot as implemented interfaces. Now, as we know, that'll take care of that statement. It'll also take care of the bullet physics statement. It will also take care of, well, we took them out already, but originally we had in there the character and server data that's coming in as iClient data. So that means that this line right here, the CPlayer instance as iClient data, is now, we don't need it anymore. However, we do need to change this because we will soon be referencing the CPlayer instance the way it is, and so I want to register it just like that. I want to say register this type so that it registers this type as that CPlayer instance, because we will be using it within things like the region and the player known list, things along those lines, and so I just want to register that type and just leave it as is with that type. So that's everything I wanted to cover in this video. With this line of code in place, we now, that just automatically also included our physics background thread that we hadn't included previously. It's also going to include all the rest of these objects as their base types. So it really takes care of a lot of the additional stuff. The only time we need to use an actual register type now is if we create a class from another class and then we need it to be registered as that class, not as one of its interfaces. But the idea is that we don't actually need to do that outside of these few exceptions, and that everything else will come from their interface types, and we'll reference them like we did here in the C player interface, referencing it as like this and actually registering with the generic interface instead of registering as a specific class. So that concludes this episode. In the next episode, we'll be taking a look at the player update, the physics background thread, which is going to set up our actual initial physics. Now, just so you guys know, this initial thing is only going to be basically a flat plane that our characters are going to run on, and if they run over the edge, they're just going to fall forever. Hopefully one of the later series videos that we'll do will take a look at exporting our level data from Unity into something that our region server can then read. We'll export it either to some kind of binary format or something, so that when we come into this background thread, we can look for that in the database based on the name of the server, and then pull that data automatically in so that our physics matches our Unity, and it becomes very seamless. Anytime we update our level, you just re-export out the physics portion, push it into the database, and then bam, the server will automatically, when it starts up, already have access to what it needs in order to have the physics working on the server, and it will be identical to what's running for the client, so that you don't have people falling through the world somewhere because there's a gap in in one of the polygons, and whoops, they fall right through. So I look forward to covering all of that material in the future. Hope you guys enjoyed it. Till then.